So first of all, thank you all for coming today. It really means a lot to every one of us here. So we're the Crossroads team. I'm Mehek. This is,
I'm Barat.
and so let's build Crossroads and take it to the cloud. So as Professor was saying before that we have a lot of test beds in our real-time communications lab, but in order to, we need to integrate them and find out how call flows, and that was the challenge of our project. So we picked this up, and instead of building a physical device on campus, we pushed this whole system to the cloud. So what does this mean? When a user on probably NG911, I'm sorry, maybe on the mobility testbed or the VOIIT testbed is making a call to NG911, this call will go through the cloud to the user registered on that testbed. So that is the system that we have developed. So as I was saying before, the first step that we did was to deploy a SIP server on our on the cloud. So the cloud that we used was Amazon Web Services. So we picked that up and we deployed an Asterisk server on the Amazon Web Services cloud. Then we connected all of our test beds, all of the proxies in our test beds to the Asterisk on the cloud. And then we further developed a dial plan which was common to each test bed. We assigned a common dial plan to each test bed so that whenever a user registered on one test bed initiates a call, the call will flow how it is intended to flow.
Okay, so our project is divided into two sides. One is the cloud, and the other one is the testbed. Is that how I sound? So on one side we got the cloud, on the other end we got the testbed user set. So let me start off by explaining to you what we started off doing on the cloud. So first we selected a virtual machine. So Amazon provides their EC2 or Elastic Cloud Computing Service where we can select any kind of machine we want. So if we want a very small server, we can do that. Or if we want something really big and main scale, we can do that too. So we just selected something that was mid-range. We put Ubuntu on it, and then we deployed an Asterisk server on that. So that's where the fun stuff starts. So first, what happened was when we tried setting up the Asterisk on it, we found out that Amazon's network works in such a way where their devices are behind a NAT. Even though they get a public IP address, they are all behind a NAT. So to solve that, we had to configure the Asterisk at boot time every time we boot these servers, or if we restart these servers, they have to be configured at boot time. And well, we did that. Then we came down to our test beds where we started connecting each and every test bed to our cloud. We made sure calls were going through. We were able to make calls from one side and receiving it on the other end and everything else. And finally, because our project requires so much persistence of connection between each and every testbed server, we also made an automated system where all the servers pings each other and make sure everybody's connected, and the cloud server pings all of the servers that it's connected to, and it starts work. And if there is a problem, it sends the administrator an email. So say if NG911 goes down, then my cloud server will be the first to know about it, and he will ping the administrator. He will send the administrator an email. I am working on getting them to tweet about it though. So here is our logical architecture. Any of the squares you see are physical machines, and the really fun one is the one on the cloud. Now I've come to call him Crowley because Crowley. So yeah, well, we have connected all of our servers up there with each one getting their own extensions. Voice over IIT main gets a 6 followed by 4 digits extension. Mobility gets a 4 followed by 4 four digits extension. NG911 they get 767, and well, if you want to call any users who are registered to the cloud server, then you just call a 2 followed by 5 digits extension. So let me try and explain this to you. This is the really fun one. So if you guys notice all the way up there, that is an, yeah. So if you guys notice all the way up there, that is our user agent, and he sends an invite to our voice over IIT main server, who's here, who then goes through the whole process of making sure that he's authorized and everything else. And at this location here, voice over IIT's server looks up at his dial plan and notices that the call that needs to be flowing through needs to go all the way up to our server on the cloud, which then comes up here. And if you guys have been paying attention, the IP address is different from here is because the cloud computer is behind a NAT. So this is its internal IP address right here. And this trace is being taken on the cloud. So over here it follows through, goes all the way in, and this call is actually a test call that is placed from a voice over IIT user to the NG911 network. So that is what we were able to accomplish. So just repeating what I'm just saying again. We were able to establish a SIP proxy on the cloud, a server on the cloud. We were able to get them to communicate with each other and make sure everybody has a persistent connection. And one thing that we noticed that we want to change in the future is our RTP packets flow through the cloud to every other server. Now, we don't want that because that takes up a lot of bandwidth, and bandwidth is a little expensive. So we're trying to figure out a way to solve that, and we will probably solve that, or whoever takes over from us will probably solve that in the future. So we're going to try and give you guys a demo. So I just need all the people whom I've asked to help me out. Please put on their little tags and stand up. All right.
Who's gonna play the cloud? Who's gonna play the cloud?
Oh, Yeah. So our NG911 call taker over there, basically you guys saw how that whole thing works, but we were able to get a call flow from here all the way up there. So let me just show you that in a second. So which one's this one? Nope. Oh, I'm sorry. It's this one and this one and I'm sorry. This is the only way I could think of showing all of you guys how the calls flow. Basically, I'm trying my best to work with it. Yeah. I should have tried working this out. I thought the resolution's going to be a little bigger, but clearly not.
We have 4 windows.
We got 4 windows. I'm not showing the 4th one just yet. So what happens is, my friend here, Sudhi from Voice over IIT Main, is going to call our NG911 server over there, and you're going to see the call show up from I can't see my mouse pointer. You're going to see the calls show up. Just, just. Well, each window is the asterisk command line interface. So every time a call shows up, it just pops up over there saying, "Hey, I'm getting a call here, but he's not to me. He's to a different server. So I'm just going to keep on forwarding the calls until the call reaches its destination." So that is what I'm trying to show you. Except just have a little, just a little bit. But we'll get this working. Please make the call. And the call starts over there, goes to NG911, and she's able to receive the call all the way over there.
You can see there.
And in the yes, and this is our mobility server, who will then call.
This iPad is registered to the mobility server, and I'm gonna call BOI.
Which then spawns, and if you notice, they go through the server to somebody else, and the call works through. So yeah, that is what we were able to do. Also, if you guys want to know, the traces were really hard to get. Yeah. So this is not part of Crossroads. I personally believe that this has to be its own project, but because of the nature of Amazon's cloud and the amount of security they put into their servers, getting a Wireshark trace from the cloud was its own was a difficulty on its own. Now, a way I was able to solve that problem was connect to the cloud using a Raspberry Pi. Run Wireshark on my remote server, pipe that data through, and then have all of that details save on a Dropbox server, and throw that up on my miniature Dropbox server. So as of right now, even right now actually, my Raspberry Pis are running round the clock, taking traces of all my servers in the cloud, and they're showing all of that on my Dropbox server, so I can access it anywhere I want. And this is done live, so that was actually really fun. So, any of you guys have any questions? Yes. Who? I haven't blocked Suspicious yet, but I have worked a quick fix for that. I just restart the server. Now, Amazon doesn't give us static IP addresses. They give us dynamic IP addresses. So if every time I restart my machine, I get a brand new IP, and you can attack me if you don't know what my IP address is. So that's how I was able to fix that. Yeah. So during boot time, Amazon needs the Astro server needs the IP address of the machine. So at boot time, I have to get the IP address of the server, attach it to my asterisk, and also get the local IP address of the server, the 10 dot address, and attach that to my asterisk. And while I'm doing that, I also need to attach a domain name to my server, which I also do at boot time. So all of these are done at boot, and then the asterisk server is configured right there, and it's all done. It's all automated to the point where I don't need to interact with my servers anymore. Yep. So anything else? Okay, going once, twice. All right, so thank you.
Thank you.